All right, 12.4's volume of prisms and cylinders. Before we start finding volume of prisms and cylinders, we should probably talk about what volume is, at least briefly. I know you've done this in previous math classes, but the volume is simply the space inside something. So if I was going to find or in the last couple sections, we found the surface area of a cube. That's the sum of all the areas of all the sides. So those are two-dimensional measurements. Well, volume is the space inside, or how much space the solid takes up. So this is going to be three-dimensional units. So all of our units in this section, or in these sections, should be cubic units, units cubed. So let's talk about finding volumes of prisms and cylinders. Well, if you look at this animation that I have here, you might it might help you figure out a way to find the formula for the prism or the cylinder. If you notice what's happening, it's this base and it's traveling along this axis down to the bottom. And we're trying to figure out that space inside. So which of the following formulas do you think will work to find volume based on this? I'm hoping you kind of got the idea here and you figured out that if this rectangle here is the area of the base of this prism, and then I travel it this many units down or up, well, I could take that area of the base and multiply it by the height, and that'll give me the volume, and it works on the prism. It works on a cylinder too. So there's your formula. It's pretty basic. Area of the base times the height, and hopefully this animation kind of helps you understand why. There's both formulas written out. Don't forget what I told you in before the surface area quiz. A prism and a cylinder are essentially the same shape. A cylinder just doesn't have a polygon base, it has a circle base. So I can replace the area of the base with just pi r squared because it's always a circle. So sometimes you'll see the cylinder written as pi r squared h, but keep in mind that's just area of the base times the height. So let's see if we can do a couple. Maybe I'll start by doing B myself and let you try A. B is a cylinder, but again, I treat these both basically as prisms. And to find the volume, I do area of the base times the height. So it's a circle. I'm going to do pi times the radius squared, and that's going to give me 81 pi. And keep in mind that area is in square feet. Then I'm going to multiply it by the height. Well, that height is 6 feet. So if I take 81 pi and multiply that by 6 feet, what I get is 486 pi. And if I take the feet squares and multiply it by the feet, I get cubic feet, to further reinforce the idea that our three-dimensional units will always be cubic units. Why don't you try this one? Well, hopefully you realized it was a prism, so you're going to do area of the base times the height. To find the area of a trapezoid, I do half the height times the sum of the bases. Maybe since I just maybe I should use brackets for that first one since I already used the parentheses. And I'm going to multiply that by the height of the prism. Keep in mind, this is the height of the base, the trapezoid. This is the height of the prism. So I'm going to do half. The height of the trapezoid is 3. I'm going to multiply that by the sum of the bases, which is 14 plus 6, the two parallel sides, because that's a 6. So I'm going to do 14 plus 6, and I get 20. I'm going to take that 30 units and that's 30 centimeters squared. I'm going to multiply it by the 5 centimeter height, and I'm going to get 150 cubic centimeters. And hopefully that's what you got as well. All right, let's keep it going. The volume of a cube is 90 cubic inches. Find the value of x. Well, this shouldn't be too bad. A cube, as we learned before, it has congruent edges. It's equilateral. So I know how to find the volume of any cube. It's area of the base times the height. And if I do area of the base, it'd be x times x, or x squared times the height of x. So the volume of a cube, you could actually just cube the side. Well, if 90 equals x cubed, well, then to find x, or the length of the edge, I'm going to take the cube root of 90. And that would be an exact answer, because I don't believe there's any perfect cubes that are going to come out of 90. No, I don't believe so. So all I can do is do that, or I can find the actual cube root of 90. Maybe I should have a calculator out for that. Should I do it real quick? What if I... All right, I'm going to bring my calculator over to find the cube root of 90, and I'm going to hit this button here, cube root of 90, and I'm getting 4.48 for the length of the edge approximately. So I'll round it to 4 point, what was it? 48. I'll round to the nearest hundredths, why not? 4.48, and the length of the edge would just be in inches. And there we go. Let's see. This Cavalari's principle just says that if I have different solids that have the same area of their base and the same height, that they're going to have the same volume. So if this square, this parallelogram, and this circle all have the same area, and they're all the same height, then their volumes are all going to be the same. Very simple. Let's find the volume of this oblique prism. Let's see what you think. See if you can do it. Well, it looks like the prism is a right triangular base. So I'm going to do area of the base times the height. The area of the base would just be half times 9 times 5, the area of a right triangle. And the height, well, since it's oblique, meaning it's slanted over, the height is just the perpendicular distance from the distance between the bases. That's just 8. They gave it to us. Don't get confused just because they made it oblique. It's still just the perpendicular distance between the bases that makes up the height. So I'm going to find the volume by taking the area of this, which would be 45 over 2, and multiply it by 8. And since 2 goes into 8 4 times, 45 times 2 is 90, times 2 is 180 cubic meters would be the volume. Hopefully you got that. So now this is like one of those ones you would have seen on the surface area test where they removed a square hole. So that's a square hole drilled through a triangular prism. Before I let you try this one, this isn't as mind-bending as the surface area ones because it's real simple. Since it's just space inside, you could just subtract the volumes. You don't have to consider any new surfaces or anything like that. So why don't you give this one a try and see how you do? All right. So all we're going to do, or all we need to do, is take the prism, which a triangular prism's volume, and I'm going to subtract the volume of the square prism. I'm going to find the volume of the triangular prism and subtract the volume of the square prism. So for the triangular prism, I'm going to do area of the base times the height. And for the square prism, I'm going to do area of the base times the height. The triangular prism, though, I have to find the area of the triangular base because the base is the triangle. Well, it's an equilateral triangle with side length of 10. What I usually do on that is realize that equilaterals are equiangular, drop down a height, use this as the half 10 is my across from the 30 and a 30, 60, 90, making the height 5 root 3, and the area half times 10 times 5 root 3. I'm going to multiply that by the height of the prism, which is the 6-foot length. So I'm just going to do this right now. I get 25 root 3 times 6. I think I'm getting 150 root 3 for the triangular prism. But now I have to subtract the square prism, which has a side length of 3. So I'm going to use the area of the base, which is 9. 3 times 3, and the height, which is the 6 feet, and I'm going to get 54, 150 root 3 minus 54, and of course that's cubic feet. So I hope you got that as well. Looks like we're already on the homework here, so we're going to wrap that up. I hope you learned a lot, and I'll see you at the next live session.